The trajectory of stealth aviation has been marked by significant innovation since the historic unveiling of the F-117 Nighthawk, the first stealth plane, by the United States in 1983. This milestone not only revolutionized military aviation, but also established an era of American dominance in low observable aircraft that endured for over 3 decades. However, the landscape of stealth aviation underwent a transformative shift in 2017 when China introduced the J-20 and Russia unveiled the Su-57, representing their foray into the realm of stealth fighters. This development not only diversified the global players in stealth technology, but also spurred a renewed and widespread interest in the development of next-generation stealth platforms. In recent years, the domain of stealth aviation has witnessed a flourishing landscape, with numerous countries actively engaged in the research and development of cutting-edge platforms. Despite persistent debates and uncertainties surrounding the effectiveness of counter-stealth technologies, such as advanced missiles and radar systems, the continued unveiling of state-of-the-art stealth aircraft underscores the enduring importance of low observability in modern air combat scenarios. Next-Generation Air Dominance, NGAD. The United States Air Force has embarked on a groundbreaking journey with the Next Generation Air Dominance (NGAD) program. This flagship project aims to redefine the capabilities of aerial warfare, surpassing even the iconic Lockheed Martin F-22 Raptor. NGAD comprises a sophisticated fighter and a penetrating counter-aircraft seamlessly integrated. This dynamic duo is designed to operate in tandem, creating a formidable force that can adapt to evolving combat scenarios. A key aspect of NGAD is the integration of unmanned collaborative combat aircraft, CCA. These unmanned counterparts work in harmony with the crewed fighter, demonstrating a revolutionary concept in man-on-man teaming, MUM-T. This collaborative approach enhances the overall effectiveness of the NGAD system. NGAD introduces loyal wingman platforms that further augment its tactical capabilities. These autonomous aircraft work in coordination with the primary system, offering support and expanding the overall combat capability of the NGAD program. The NGAD program sets far-reaching objectives that encompass advancements in propulsion, stealth, weaponry, digital design, CID-based engineering, and thermal management. This holistic approach ensures that the NGAD system achieves unmatched air dominance by addressing multiple facets of aerial warfare. Setting itself apart, NGAD adopts a unique development approach by segregating design, production, and support functions. This innovative strategy, coupled with a substantial budget of $9 billion allocated through 2025, underscores the commitment to achieving air dominance through cutting-edge technology. FAXX. The FAXX program takes on the crucial mission of replacing the aging F/A-18 EAF Super Hornets, ensuring that the United States Navy maintains a cutting-edge air superiority capability. By complementing the capabilities of the F-35C, the FAXX program aims to create a formidable and adaptable fleet for the future. Key features and requirements of the FAXX include super cruise capabilities, advanced stealth features, and a diverse range of mission capabilities. From air combat and ground attack to surface warfare and close air support, the FAXX is designed as a multi-role powerhouse, capable of excelling in various operational scenarios. In its quest for superiority, the FAXX program explores next-generation technologies, such as maximum sensor connectivity and electronically configured smart skins. These innovations aim to enhance overall performance, providing the Navy with a technological edge in the evolving landscape of aerial warfare. The FAXX is envisioned as a highly adaptive platform that accommodates manned, unmanned, and optionally manned operations. Its open architecture design allows for flexibility in integrating different sensors, payloads, and weapons, catering to specific mission requirements and ensuring versatility in naval operations. Collaborative efforts with the U.S. Air Force focus on next-generation tactical fighter development. This collaboration prioritizes the integration of a wide array of advanced weaponry to overcome or suppress enemy air defenses. The FAXX program, although trailing the Air Force's NGAD effort by a few years, aims to increase payload capacity and unrefueled range. countering strategic challenges posed by long-range anti-ship missiles in the Pacific. Designed to operate from American carriers, the FAXX program is strategically positioned to engage Chinese targets from a safe distance. This capability addresses the challenges posed by China's long-range anti-ship missiles in the Pacific, reinforcing the Navy's commitment to maintaining maritime dominance. B21 Raider. The Northrop Grumman B21 Raider, a cornerstone of the United States Air Force's Long-Range Strike Bomber (LSB) program, emerges as a cutting-edge strategic bomber poised to redefine air dominance. Positioned to replace the aging Rockwell B-1 Lancer and Northrop Grumman B-2 Spirit by 2040, with potential succession of the Boeing B-52 Stratofortress thereafter, the B-21 Raider represents a new era in long-range precision strikes and high survivability. Operating under a veil of high classification, the B-21 Raider keeps many technical details shrouded in secrecy, underscoring its status as a technological marvel. The first glimpses of this advanced bomber were unveiled in December 2022 during a rollout ceremony at Northrop Grumman's production facilities in Palmdale, California. Renderings of the B-21 showcase distinctive flush and blended inlets, hinting at a smaller and lighter design compared to its predecessor, the B-2 Spirit. The anticipation is that the B-21 will feature engines similar to the F-35's Pratt & Whitney F-135, contributing to cost reduction and enhancing operational efficiency. Positioned as the world's first sixth-generation aircraft, the B-21 Raider is designed for long-range precision strikes with high survivability. Its next-generation stealth technology and advancements in low observable processes make it a formidable force capable of penetrating even the most robust defenses globally. The B-21 Raider's open architecture allows for rapid upgradability, enabling the seamless integration of new weapons and software upgrades to adapt to evolving threats. Northrop Grumman employs agile software development and digital engineering tools to mitigate production risks and usher in modern sustainment practices for the B-21 program. Ground testing has showcased the effectiveness of digital modeling, surpassing industry standards and setting a new benchmark. The B-21's digital ecosystem spans its entire life cycle, incorporating advanced manufacturing, augmented reality for technicians, and efficient integration of supplier parts, enhancing efficiency and reducing risk. Despite its smaller size compared to the B-2 Spirit, the B-21 Raider aims to compensate with unparalleled mission versatility. Optionally manned and boasting unprecedented stealth capabilities, it serves as a new nuclear weapon delivery vehicle while also functioning as a high-powered sensor node and intelligence and reconnaissance platform. This brings the airborne leg of America's nuclear triad into the 21st century. The Shenyang FC-31 Gear Falcon. Introducing the Shenyang FC-31 Gear Falcon, a Chinese prototype mid-size twin-jet fifth-generation fighter developed by Shenyang Aircraft Corporation, SAC. The FC-31 Gear Falcon, smaller than the Chengdu J-20, takes center stage in China's quest for advanced fighter technology. This mid-size twin-jet fighter is designed to meet the evolving demands of modern warfare, incorporating stealth features and combat capabilities that align with China's strategic objectives. Details about the FC-31 Gear Falcon remain closely guarded, adding an element of intrigue to China's pursuit of advanced air capabilities. Speculations abound regarding its potential role as a carrier-based fighter, indicated by the twin-wheel nose landing gear. Despite the secrecy, the FC-31 plays a pivotal role in China's efforts to advance its fighter technology. Analysts suggest that the FC-31's design may draw influences from both the F-35 and F-22, citing similarities in platform shape, aerodynamics, and airframe configuration. This melding of influences highlights China's strategic approach to leverage the strengths of proven fighter designs in the development of the FC-31 Gear Falcon. The FC-31 features two internal weapons bays, each capable of carrying two medium-range missiles, complemented by heavy and light hardpoints on each wing. Additive manufacturing has streamlined production, resulting in a 50% reduction in components compared to similar aircraft. This emphasizes China's commitment to efficiency and combat effectiveness. Equipped with RD-93 engines, the FC-31 is expected to see improvement with the development of the WS-13 variant, boasting 100 kilonewtons of thrust. These advancements signify China's dedication to enhancing the performance and capabilities of its indigenous fighter aircraft. Claiming stealthiness against L-band and C-band radars, the FC-31 is designed to be low observable against various multispectrum sensors. Ongoing efforts to redesign engine nozzles aim to further reduce radar and infrared signatures, highlighting China's commitment to advancing stealth capabilities. Zean H20. In the dynamic realm of strategic aviation, China is making substantial advancements with the development of the Zean H20, a projected subsonic stealth bomber meticulously designed for the People's Liberation Army Air Force, PLAAF. The Zean H20 represents China's first dedicated strategic bomber, marking a significant milestone in the nation's pursuit of advanced aviation capabilities. Positioned as a vital project by the PLA, the H-20 is envisioned to play a transformative role in the strategic landscape. Envisioned in a flying wing configuration, the H-20 aims to achieve a remarkable range exceeding 8,500 kilometers and an impressive payload capacity of at least 10 tons. This design choice reflects China's commitment to innovation in strategic aviation, with potential implications for global security dynamics. According to the United States Department of Defense and noted by the RAND Corporation, the strategic range of the H-20 could empower China to reliably threaten U.S. targets, extending from key military bases in Guam and Hawaii to regions beyond the second island chain. This strategic capability marks a significant leap for China in projecting power on a global scale. Over the years, glimpses of the H-20's design have circulated, with recurring features captured in various models and computer-generated images. Defense analysts have noted serrated air intakes, cranked kite wings, and foldable twin-tail surfaces, showcasing adaptability between horizontal tailplanes and V-tails. Rumors of a Chinese stealth bomber surfaced in the late 1990s, gaining traction in 2014 with China Daily's emphasis on an intercontinental strategic bomber. In 2018, China seemingly confirmed the flying wing design, reminiscent of the US B-2 bomber. A video released by the Aviation Industry Corporation of China showcased an aircraft bearing striking similarities to Northrop Grumman's B21 Raider, solidifying China's commitment to advanced strategic capabilities. Analysts suggest that the H-20 aligns closely with China's strategic goals, with a Pentagon assessment in 2021 positioning it in proximity to the formidable B-2 in terms of capability. Sukhoi Su-75 Checkmate. The Sukhoi Su-75 Checkmate, a single-engine stealth fighter aircraft currently in development by Sukhoi for both export and the Russian aerospace forces, faces a complex landscape marked by international sanctions and trade limitations. Also known as the T-75, this innovative aircraft encounters potential delays in its development due to constraints on the use of US dollars in trade. The Su-75 Checkmate, a single-engine stealth fighter, is navigating the intricate landscape of development challenges, including international sanctions and limitations on trade. This innovative aircraft, designed for both export and the Russian aerospace forces, strives to carve a niche in modern aerial warfare. Boasting advanced features, the Su-75 incorporates a diverter supersonic inlet, DSI, a distinctive V-tail design, and internal weapons bays, all aimed at reducing radar signature. These features contribute to the aircraft's stealthy and aerodynamically efficient configuration. With an impressive range of 3,000 kilometers, a payload capacity of 7,400 kilos, and speeds ranging from Mach 1.8 to 2.0, the Su-75 demonstrates exceptional operational capabilities. Equipped with a diverter supersonic inlet, it ensures efficient air intake at high speeds, enhancing overall performance. At the heart of this advanced fighter is the Saturn ISDEL 30 engine, contributing to superior overall performance and agility. This powerhouse engine positions the Su-75 Checkmate as a cutting-edge and formidable asset in modern aerial warfare. Recent developments in the Su-75's design, as revealed in patents published in 2023, focus on reducing radar signature, increasing lifting surface area, and incorporating the advanced Saturn ISDEL 30 engine. These modifications underscore Sukhoi's commitment to enhancing the aircraft's stealth capabilities. Recent media coverage raises uncertainties about the Su-75 Checkmate's classification as a stealth fighter. For a nation prioritizing information operations, questions arise about the aircraft's actual military capability, compared to its emphasis on media narratives. The Su75 Checkmate stands at the intersection of technological innovation and strategic considerations, navigating challenges to establish its position in the evolving landscape of aerial warfare. Tupolev PACD. In the ever-evolving realm of next-generation strategic bombers, the Tupolev PACD emerges as a flagship project currently under development by Tupolev for the Russian Aerospace Forces. With the primary goal of complementing and eventually replacing the aging Tu-95, the PACD plays a crucial role in Russia's strategy to counter potential threats posed by advanced American bombers, like the B-2 and the upcoming B-21. Designed as a successor to the aging Tu-95, the PACD stands at the forefront of Russia's efforts to modernize its strategic bomber fleet. With a focus on countering advanced American counterparts, this next-generation bomber aims to enhance Russia's capabilities in the evolving landscape of strategic aviation. Comprehensive analysis of the PACD proves challenging due to its developmental phase, subjecting it to intentional propaganda and unintentional misconceptions found in open-source outlets. As the bomber progresses through its development, separating fact from speculation becomes crucial for a clear understanding of its capabilities. According to information from TASS, a media outlet owned by the Russian government, the PACD is anticipated to feature a flying wing design akin to the B-2 Spirit. Subsonic in nature, the bomber is projected to possess heavy payload capabilities, enabling it to launch cruise missiles, precision bombs, and potentially hypersonic weapons. While aspirations for the PACD likely match the capabilities of the B-2, surpassing it remains uncertain. Russia, similar to China, recognizes the importance of investing in heavy payload stealth bombers, reflecting the evolving dynamics of strategic aviation. Originally slated to make its first flight within a specific timeline, the PACD's schedule has likely been disrupted due to Russia's ongoing invasion of Ukraine. This underscores the challenges posed by geopolitical events and international developments in the execution of complex military projects. As the PACD progresses through its developmental phases, the global strategic landscape awaits further revelations about its design, capabilities, and potential to redefine Russia's aerial capabilities in the years to come. The disrupted timeline serves as a reminder of the complex interplay between geopolitics and the development of cutting-edge military technology. Thai TF-Con. Embarking on a journey to develop its first indigenous fifth-generation fighter, Turkey proudly unveils the Turkish aerospace industry's TF-Con, also known as TAI. The late 2022 revelation of the prototype marks a significant milestone in Turkey's ambition to join the elite ranks of nations possessing advanced stealth fighters such as the F-22 and the F-35. The TF-Con, born out of the TFX program initiated in 2010, signifies Turkey's commitment to reducing dependence on foreign military technology and establishing a formidable fifth-generation fighter under its banner. The TFX program, now named Tayan, represents a bold leap for Turkish aviation. Initiated in 2010, the program has evolved into Tayan, showcasing the nation's determination to attain indigenous fifth-generation fighter capabilities. However, challenges have arisen, including shifts away from initial plans to purchase F-35s and concerns about sourcing American-made fifth-generation engines. Distinguished as the first fifth-generation aircraft incorporating digital twin technology, the Tayan reflects advancements in design and production. The involvement of TAI's advanced carbon composites fuselage facility, previously associated with Lockheed Martin's F-35 program, underscores the commitment to cutting-edge materials and manufacturing processes. Elan, a key player in the Turkish defense industry, stands at the forefront of developing advanced radar capabilities for the TFX program. The active electronically scanned array radar, utilizing gallium nitride (GaN) technology, promises superior performance. The integration of encrypted data link connections allows seamless communication between the cockpit and accompanying UAVs, presenting a holistic approach to air superiority. The Tayan's power plant options introduce an element of flexibility to its design. While prototypes initially employed General Electric F-110 engines, future iterations anticipate the readiness of the TAC engine, a collaborative effort between Turkish Kale and British Rolls-Royce. An undisclosed alternative engine option adds further versatility to the TFX powerplant choices. In the dynamic landscape of advanced air superiority fighters, the T-Cayenne emerges as a symbol of Turkey's technological aspirations. The determination to carve its path in the realm of fifth-generation aviation is reflected in the development and capabilities of the TF-Con, showcasing Turkey's commitment to technological excellence. KAAI KF-21 Boramai. The KAI KF-21 Boramai, formerly known as KFX, represents South Korea's ambitious leap into advanced fighter aircraft development. A joint program aimed at meeting the needs of both the South Korean and Indonesian air forces. The KF-21 strives to create a cutting-edge multi-role fighter with stealth capabilities surpassing fourth-generation counterparts. The KF-21 Boramai, initially named KFX, emerges from a South Korean fighter aircraft development program, targeting the creation of an advanced multi-role fighter. The program sets its sights on delivering a fighter with stealth capabilities that outclass fourth-generation counterparts. Initial plans did not include internal weapon bays, characteristic of fifth-generation fighters, but future considerations may introduce this feature. Originally conceived as a single-seat, twin-engine, multi-role fighter, the KF-21 aimed to surpass the capabilities of the Dassault Rafale and Eurofighter Typhoon, falling slightly short of the Lockheed Martin F-35 Lightning II. Recommendations from the Weapon Systems Concept Development and Application Research Center emphasized superiority in combat range, airframe lifespan, avionics, radar capabilities, specifically AESA radar, electronic warfare, and data link capabilities. The Republic of Korea Air Force, ROKAF, later downgraded the project's requirements to a 4.5-generation fighter with limited stealth capabilities. South Korea, possessing 65% of the necessary technology, sought international cooperation to enhance the program's capabilities. The proposed concepts for the KF-21 included designs resembling the F-35, C-13, and European fighters, C-23, with the choice dependent on potential development deals with US or European partners. The Defense Acquisition Program Administration, DEA, proposed the C-51 KFXE, a smaller single-engine fighter, aiming to reduce costs. However, this design fell short in performance compared to the F-16 and was deemed unsuitable for Indonesia's expansive airspace. The Republic of Korea Air Force favored the advantages of a twin-engine configuration, emphasizing better combat performance, safety, and future upgrade potential. Despite facing challenges, including technology transfer obstacles, a critical design review in September 2019 confirmed that the KF-21 met the Republic of Korea Air Force's requirements. This marked a significant milestone in the program, showcasing South Korea's resilience in overcoming challenges and advancing its domestic capabilities. The confirmation of meeting the Republic of Korea Air Force's requirements in the Critical Design Review of September 2019 represents a significant milestone for the KF-21 Boramai program. This achievement underscores South Korea's commitment to technological excellence and its pursuit of a domestically developed advanced multi-role fighter. Global Combat Air Program, GCAP. The Global Combat Air Program, GCAP, stands as a groundbreaking initiative, uniting the collaborative efforts of the United Kingdom, Italy, Japan, and potentially Sweden. Originating from the UK's Tempest program, GCAP has evolved into a multinational venture with the recent inclusion of Japan. This cooperative endeavor aims to develop a shared sixth-generation fighter, merging the UK's Tempest program with Japan's FX initiative. The overarching objective of GCAP is to field a cutting-edge sixth-generation fighter by the year 2035, rivaling the capabilities of existing initiatives such as the United States Next Generation Air Dominance, NGAD, and the Future Air Combat System, FX. Initially associated with the UK's Tempest program, GCAP has grown into a multinational initiative with the inclusion of Japan. This expansion reflects a strategic convergence of expertise, resources, and technological capabilities from participating countries. The primary goal of GCAP is to develop a shared sixth-generation fighter that possesses capabilities comparable to advanced initiatives such as NGAD and FAX. This cutting-edge aircraft is envisioned to incorporate artificial intelligence, enabling it to fly alongside AI-enabled drone wingmen, thereby enhancing its combat effectiveness and versatility. The intended outcome of GCAP is to replace existing fleets of fighter jets, including the UK's Eurofighter Typhoon and other aircraft currently in service with Italy, Japan, and potentially Sweden. This unified vision emphasizes fleet modernization and the adoption of state-of-the-art technologies to ensure a competitive edge in combat aviation. The collaborative effort was solidified with a joint announcement on December 9, 2022. The governments of Japan, the United Kingdom, and Italy expressed their commitment to jointly develop and deploy this unified sixth-generation fighter. This joint commitment underscores the dedication of the participating nations to advancing defense capabilities through international collaboration. HAL MCA. India's foray into cutting-edge 5th and 6th generation aviation technologies is embodied in the HAL Advanced Medium Combat Aircraft, MCA. More than just a quest for a state-of-the-art stealth multi-role combat aircraft, the AMCA program signifies India's steadfast commitment to nurturing indigenous capabilities and maintaining a leadership position in advanced aerospace technology. The Horizon 2047 document outlines a strategic roadmap for joint development with France, emphasizing the synergy in technological advancements. India's collaboration with France and the United States in developing engines for the AMCA highlights the global partnerships integral to the program's success. The AMCA's design is a marvel, featuring diamond-shaped trapezoidal wings, a stabilator V-tail, and a unique profile aimed at reducing drag. The focus on radar stealth is evident through innovative design elements such as S-shaped air intakes, body-conformal antennas, and low-intercept radar. Incorporating distributed passive sensors coupled with AI-assisted multi-sensor data fusion, the AMCA achieves unprecedented levels of situational awareness. This advanced capability enhances the aircraft's ability to navigate modern air combat scenarios with precision. Equipped with a formidable UDUM-AA radar, using gallium nitride (GaN) technology mounted on a mechanically steerable mount, the AMCA ensures advanced radar capabilities crucial for contemporary air combat scenarios. This technology positions India at the forefront of radar innovation. India's ambitious timeline for the AMCA program is evident in the scheduled prototype flight set for 2028. This milestone not only showcases India's technical prowess, but also signifies its determination to field a high-tech jet capable of competing with the latest global developments in aviation technology. Mitsubishi FX. Japan's ambitious venture into stealth fighter development is exemplified by the Mitsubishi FX, marking a paradigm shift in the nation's defense capabilities. Positioned to achieve air superiority and replace the Mitsubishi F2, the FX represents not only a technological leap, but also a strategic move to strengthen Japan's defense industry and potentially engage in international arms sales. The FX incorporates electric actuators, departing from conventional hydraulic systems. This technological shift streamlines installation, reduces weight, and enhances the aircraft's overall mobility. This move reflects Japan's dedication to cutting-edge technology to stay at the forefront of fighter development. To ensure effective detection against stealth aircraft, the FX integrates advanced sensors, including an AESA radar, a passive RF sensor, and an infrared camera. This sophisticated sensor suite contributes to the aircraft's situational awareness, demonstrating Japan's commitment to staying ahead in the realm of stealth technology. To minimize its radar cross-section, the FX adopts serpentine air ducts and an internal weapons bay. Innovative technologies such as electromagnetic wave absorbers and metamaterials are employed to significantly reduce radar reflection, showcasing Japan's dedication to achieving a high level of stealth capability. Powered by two XF9 engines with adaptable thrust levels, the FX features a slim design to accommodate internal weapons. The inclusion of three-dimensional thrust vector nozzles enhances maneuverability, reflecting Japan's commitment to advanced propulsion systems. As Japan positions the FX as a sixth-generation fighter jet, the program not only signifies technological prowess, but also exemplifies Japan's strategic vision for a formidable air superiority platform. Collaborative efforts with the UK and the inclusion of Avio Aero in the engine development project underscore Japan's commitment to collaborative advancements in aerospace technology. The FX, with its blend of innovation and international cooperation, emerges as a symbol of Japan's quest for excellence in the realm of stealth fighters. The memorandum with the UK and the inclusion of Avio Aero in the engine development project highlight Japan's commitment to collaborative advancements in aerospace technology, placing the FX at the forefront of global stealth fighter development.